Hey guys, in this next video we're going to look at how to actually solve equations. We're going to look at addition and subtraction equations in this video, and then in the following video we'll look at multiplication and division equations. So in order to solve or again find the solution of an equation, the solution being the answer, we use what are called inverse operations. And inverse operations undo the operations within the equation. Your goal when you're solving any kind of equation is always to isolate the variable. And for those of you who don't know what isolate means, it means get the variable by itself on either the left or the right side of the equation. So hopefully you know already that the inverse of addition is subtraction, and that the inverse of subtraction is addition. Those are called inverse operations because one operation will cancel the other one out. Okay, so we're going to use that fact today when we're solving these equations. And one important tip to remember is that equations are like balances. If you've ever used a balance in science class, you know that in order to keep a balance balanced, whatever you do to one side of the balance, okay, whether it be adding weight or taking away weight, you have to do the exact same thing to the other side of the balance. Okay, so anything we do to one side of an equation, we must do the exact same thing to the other side. So let's take a look at each of these examples and practice solving these equations. So example 1, we have the equation x plus 13 equals 27. The goal is to isolate x, okay, get it by itself, and that means that because the left side of the equation has an x plus 13, we need to do the inverse of this addition, okay? What will undo this adding 13? Well, subtracting 13 will undo the adding 13. So we write a minus 13, and notice how I'm writing that directly below the plus 13. Make sure you're doing that as well. We do that once on the left side of the equation, and in order to keep this equation balanced, we must also do that once on the right side of the equation. So we subtract 13 from 27. So now, on the left side of the equation, this positive 13 and this minus 13, 13 minus 13 is 0, so they cancel each other out. So you're just left with the variable x on the left side. On the right side of the equation, here's my equal sign, we have 27 minus 13, which is 14. So we get an answer of x equals 14. We can check that answer by doing what we did in the last video and substituting this solution, 14, in for x in the equation and seeing if we get a true statement. So let's do that. Okay, we'll check our answer by taking 14, replacing x with 14, and then checking to see if this is a true statement. 14 plus 13 equals 27. 14 plus 13 is 27, and so that works. Okay, let's look at number 2. This time our equation is 18 equals 6 plus w. This time the variable is on the right side of the equation, and so I want to focus on getting w isolated on the right side, and that means I need to find a way to get rid of this 6. Since we're adding w and 6, I can again do subtraction, subtract 6 from the right side to cancel out this positive 6 here. And to keep this equation balanced, I'll do the same thing on the left side. So on the left side, we have 18 minus 6, which is 12, equals, we have 6 minus 6 on the right side, so those cancel each other out, and we're left with just w on the right side. So we get an answer of w equals 12, which is the same thing as 12 equals w. Let's check that answer just to make sure we didn't make a mistake. So we're substituting a 12 in for w into this original equation. So this is 18 equals 6 plus 12, and 6 plus 12 is equal to 18, so that does check out. Okay, number 3, m minus 10 equals 2. So we want to isolate the m, and that means we want to get rid of this subtract 10. Well, the inverse of subtraction is addition, so I'm going to add 10 to the left side of this equation to undo this subtraction. And to keep the equation balanced, I need to do the same thing on the right side. Add 10 to 2. So I get on the left side m, my negative 10 and my positive 10 cancel each other out. So I get m equals 2 plus 10, which is 12. Let's check and make sure that 12 is in fact the solution. So we're substituting 12 in for m into the equation. 12 minus 10 equals 2. 12 minus 10 is 2, and so that works. Okay, number 4, 7 equals b minus 3. So I see subtraction on the right side here with the b, so I need to use addition to undo that. So I'm adding 3 here on the right side, and I'm keeping the equation balanced, so I'm also going to add 3 on the left side. Okay, so on the left side, 7 plus 3 is 10 equals negative 3 and positive 3 cancel each other out, and so we're just left with 10 equals b, or b equals 10. Go ahead and check that answer. So the equation was 7 equals b minus 3, so substitute 10 for b, and 10 minus 3 is 7, so that works. Okay, going to the back side, number 5, we have y plus 3 equals negative 10. So I see addition on the left side of the equation with the variable, so I need to use subtraction to undo that. So we'll be subtracting 3 from the left side and also subtracting 3 from the right side. So on the left side, my 3 and my negative 3 cancel. I get y equals negative 10 minus 3, remember your integer rules, is going to be negative 13. So y equals negative 13. Let's check. Substitute negative 13 in for y. Negative 13 plus 3 equals negative 10. Negative 13 plus 3, again, think about your integer rules. If you have 13 negatives and you combine that with 3 positives, take the difference of those numbers and you're left with negative 10. So that works. Okay, number 6, negative 3 plus a equals negative 18. Okay, be careful on this problem here. So you do see addition here between the negative 3 and the a. However, think about what operation do we want to do to cancel out this negative 3. Okay, if you try to do subtraction on this side and you write a minus 3 because of this addition sign here, negative 3 minus 3 is negative 6. It's not 0. Okay, you want to cancel out this negative 3. So the way we cancel out a minus 3 is by putting a plus 3 below it. Negative 3 plus 3 is 0. So the sign that you use, addition or subtraction underneath the number, should always be the opposite of the sign on the original number. Here we had a plus 3 and we used a minus 3. On number 4 we had a minus 3 and we used a plus 3. Okay, so focus on the sign in front of the number you're trying to get rid of, and in this case the opposite of this minus 3 is adding 3. So we add 3 here on the left side. We must also add 3 on the right side. Negative 3 plus 3, these cancel each other out, so we're left with a equals negative 18 plus 3, and negative 18 plus 3 is equal to negative 15. Okay, and we'll want to check just to be sure. The equation was negative 3 plus a equals negative 18. So we have negative 3 plus, and then we're substituting negative 15 in for a, equals negative 18. Well, we know a plus minus should always be written with a minus, so this is negative 3 minus 15. And when you're combining two negatives, negative 3 minus 15, that does give you negative 18. Okay, we're going to skip example 7 here on your notes, so feel free to just go ahead and cross this one out. If you have any other questions over this video, make sure those are written down for the next time. And until then, have a nice day. You're all wonderful people. Take care.